So is it audible?
Yes, sir.
How many participants, how many students have joined this lecture?
37, sir.
Why today the strength of student is very less? Is there any specific reason? All of you got breaks at appropriate time. Can someone put a message on a group so that others can join?
Okay, sir.
It's almost 3 o'clock and very less participants are there, very less students are there. 52, now I think it's 52, right? So don't comment your roll number right now. I will ask you once it is done, I will ask you to write your roll number and name into the chat box so that I can take a snapshot or a screenshot of it, right? Within 1 minute, I'm going to start. Right? Don't write your roll numbers. I will ask you, then you can put your roll number into the chat box. So I think enough. 77 is the strength. So shall we start? 79. Shall we start without waiting for latecomers?
Yes, sir.
Yes, sir.
Okay. Okay. So today's topic of our discussion is electric field intensity. So this is electric field.
एक्सक्यूज मी सर.
हाँ
सर गेल्या लेक्चर मध्ये प्रॉब्लेम अर्धच राहिलाय आपलं.
अर्धाच राहिलाय.
हां सर.
आन्सर आलाय. I think this was the problem, right?
येस सर.
We have solved it completely. And this is the answer.
येस सर. सॉरी सर.
F bar is equal to 16.56 F bar Z Newton is the answer for a problem that we have studied in last lecture, right? So shall we proceed?
ओके सर.
Shall we proceed? So today we will discuss the electric field intensity. Basically, this new term, new parameter of electrostatics is denoted by E. Capital letter E is used to denote this electric field intensity. Now, this is actually a vector term, vector quantity, hence it has to be mentioned like E bar. So electric field intensity is represented as E bar. Now, just to understand this electric field intensity, we will just take a look at this Coulomb's law once again, and then we will proceed. So Coulomb's law gives you the force between 2 point charges, right? So force is directly proportional to product of magnitude of charges. Also, it is inversely proportional to square of distance between them, and it depends upon the medium, right? So this is what Coulomb's law says. This is what the aspects related with Coulomb's law are. Now, once again, let us take an example of a point charge. So suppose, is it visible? Is it clearly visible?
येस सर.
Yes, sir.
So let us take example of point charge. Let's say the point charge is positive. So in that case, what would be the direction of lines of force? Those lines of force will be moving radially outward, right? So this is point charge, positive point charge, and the lines of force, they are moving radially outward, right? Next, if I talk about exactly opposite of this situation, so if I'm having a point charge but a minus q, then in that case the lines of force will be moving radially inward towards this point charge, right? So these are the lines of force. Now, if I place any of the point, let's say test point somewhere here, right? So let us assume the test charge is small q. Test charge is indicated by small q. So what it will experience according to Coulomb's law? This test charge will experience the force, right? So this is the direction of force from plus q to this test charge q. It will experience the force, and in that case we have written the formula for force between those two charges. So force is equal to F bar is equal to, or let's say simply F is the magnitude of force acting between those two charges. F is equal to Q, test charge Q, upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught is the medium constant, right? So Q upon 4 pi epsilon naught r square. R square is the square of distance between them, and a bar r, of course it would be a direction, right? So this is the formula for force acting between those two charges. Now I'm going to define electric field intensity. Now electric field intensity is defined as force per unit charge, right? Electric field intensity is defined as force acting per unit test charge, right? So if I want to write this mathematically, so the force per unit charge is exerted on test charge. If I want to write it mathematically, this will give you the electric field intensity. So electric field intensity E bar, or let's say simply E, that denotes magnitude of E, is equal to F upon Q, because it's force upon charge, right? So F upon Q. So you can get the value of this F from this equation. So let me write this as equation number 1, right? And in this equation, we will put the value of F from equation 1. So what you will get? This is equal to Q upon Q 4 pi epsilon naught r square, right? So this test charge QQ gets cancelled. And finally, what we get is E bar is equal to, E is equal to F upon Q. Rather, I should write now here simply Q upon 4 pi epsilon naught r square. So this is the formula for electric field intensity. So unit of this electric field intensity is actually volts per meter, right? And if I write this in terms of force divided by charge, it will be Newton per Coulomb, right? Now I want to express this in terms of a vector, right? So since electric field intensity is a vector term, so electric field intensity you can write as E bar is equal to Q upon 4 pi epsilon naught r square A bar r, right? So this is the electric field intensity in a vector form, right? So any doubt up so far? Do you have any doubt so far? Force upon Q के लिए क्या होता है? Electric field intensity.
No,
So
sir.
electric field intensity is Q upon 4 pi epsilon naught r square A bar r. This is the formula. Now to make it simple, if I'm having 2 point charges, let's say point charge Q is present here, and if I'm trying to find the electric field intensity at this point, right? So at this point, what would be the electric field intensity? E bar is equal to q upon 4 pi epsilon naught r square. R square means r is the distance between those two charges, those 2 points, and a bar r is the direction. So this direction is a bar r, right? So this is for simplicity. Now there would be a problem. There would be a problem when multiple sources, multiple charges are present in that space, and if you want to find the total electric field intensity at a particular point because of multiple charges, in that case, what would be the solution? For example, let me give you the scenario. Suppose I am having point P where I want the electric field, total electric field. But the electric field is created because of, let's say, Q1, which is placed somewhere here, right? So Q1 would generate the electric field intensity, that's E1, right? E1 will be the E1 is the electric field intensity produced by Q1 at P, right? Similarly, I will have some point charge somewhere here, let's say Q2, and because of this point charge Q2, electric field intensity produced at P. That electric field intensity, let's say it is E2 bar. Then we have, let's say, another point, say Q. Because of this Q3, we will have electric field intensity produced at point P. So let's say that the electric field intensity is E3, right? So all of them are making, they are just at a distance R1. So let's say this vector is R1, this vector is R2, this vector is R3, and so on. So you may have such n number of charges. So let me write here Qn, right? So Qn will have electric field intensity at point P, that is making Rn vector, and electric field intensity would be, this is so on up to En. I'm talking about number of or multiple charges, right? So at the end, if I want to calculate this electric field at point P, what would be the solution? What we can proceed to find this electric field at point P? Any judgment? How to calculate electric field intensity at point P because of multiple charges?
Summation करायचे.
Summation करायचं, right? But we call it as a principle of superposition, right? So with this, let us understand what is principle of superposition. So in that case, we know that all those R1, R2, R3, and so on up to Rn, these are the vectors. So from those vectors, you are able to find the unit vectors. Unit vectors associated with those vectors are a bar R1, comma a bar R2, comma a bar R3. This is so on up to a bar Rn. Right? These are the unit vectors that you can calculate if the proper information is given to you. Right? So once we know the vector, once we know the unit vector, we can calculate E1. How will you calculate E1 bar? By using the formula for electric field intensity. E1 कैसा calculate करना? E1 is equal to Q1 upon 4 pi epsilon naught R1 square a bar R1, right? So this is the formula. This is how you can calculate the electric field intensity at point P because of charge Q1. Similarly, I can proceed to calculate the electric field intensity at point P because of charge Q2. So this electric field intensity at point P because of charge Q2 is equal.
Excuse me, sir.
बोला. Hello.
Half screen display. Half display, sir.
Blur दिसतंय? हाफ स्क्रीन दिसते? हॅलो, थोडंसं रेंज मध्ये. आता दिसतंय?
हाँ सर हाँ
क्लियर दिसता था?
हाँ
Shall I proceed? Shall I
yes, sir.
proceed? So E2 will be the electric field intensity created at point P, right? And because of whom it is created? Because charge Q2. So the formula to obtain this electric field intensity E2 is Q2 upon 4 pi epsilon naught R2 square A bar R2, right? So this is how you can calculate the electric field intensity for second charge, that is Q2. Because now, see, if we are finding electric field intensity at a particular point, let's say point P, because of multiple charges, what is the solution? Solution is principle of superposition. Now I will tell you the meaning of principle of superposition. So every individual electric field intensity we are going to calculate, right? Once we calculate every individual electric field intensity, we will add those individual electric field intensity to obtain the total electric field intensity at that point, right? So this is the principle of superposition. So I have calculated electric field intensity because of Q1, because of Q2. Similarly, I can write expression for E3. E3 is equal to Q3 upon 4 pi epsilon naught R3 square A bar R3. And in general, E bar N. E bar N is equal to Qn, right? So this is the Qn upon 4 pi epsilon naught Rn square A bar Rn, right? So these are the electric field intensities that you can calculate. Now, next step is to add all those electric field intensity. So to obtain total electric field, so E bar at point P, this is total electric field. E bar at point P is equal to E1 bar plus E2 bar plus E3 bar plus this is so on up to En bar, right? Now put up the values of E1, E2 and E3. So I can write here Q1 upon 4 pi epsilon naught R1 square A bar R1 plus Q2 upon 4 pi epsilon naught R2 square A bar R2. This is so on up to Qn upon 4 pi epsilon naught Rn square upon A bar Rn, right? So this is how you can add all those. Now, since 1 upon 4 pi epsilon naught is a common term, I can take it outside of this summation. So E bar at P is equal to 1 upon 4 pi epsilon naught, right? So this is outside of this summation. Inside the summation, what things are remaining? So let me give a variable. So I is the variable is equal to 1. So value would start from 1 to, let's say multiple charges are there. So let's assume it is 1 to n, right? So this is Q1, Q2, so on up to Qn. That's why I can rather replace this by Qi divided by Ri square A bar Ri. So this is the formula for obtaining electric field intensity at a particular point because of multiple charges. Is there any doubt so far? Is there any query? समझते?
Yes, sir.
Shall we proceed? Citizen Alit, how many are there? 103. Now you can write your roll number and name in the chat box. I will take the snapshot. All of you, write your roll number. गेस्टचं काय झालं? गेस्ट बघा की. आहेत का गेले बघा. हां. I can see 105 participants, but I can see in chat box only 99 comments are there. So those who are remaining, make a comment, write your roll number, write your division, write your name. Net अजून चालू झालं नाही. So shall we solve one example on this? One or two example on this? If you are ready
Yes,
with if you are ready with pen and notebook, we will solve one example. So take the example. Let a point Q1. Let a point. Let a point charge Q1 is equal to 25 nanocoulomb be located at point A in bracket 4 comma 2 minus 2 comma 7 4 comma minus 2 comma 7, right? So you have given with let's say charge Q, rather writing this as a Q1, I will write it as a simple Q. So make it Q. Q is equal to 25 nanocoulomb located at a point A, that is 4 comma minus 2 comma 7. So find electric field intensity, find E bar at let's say point B in bracket 1 comma 2 comma 3, right? So this is the example, and what information is given to you? Point A and point B are given. So let us assume point A is here. A is having coordinates 4 comma minus 2 comma 7, and point B is having coordinates 1 comma 2 comma 3. So these are the coordinates of point B. Now let us assume, or let us take this charge Q on point A. So Q is equal to 25 nanocoulomb is located at point A, right? So because of that, we need to find the electric field intensity at point B, and the coordinates of point B are given. So for that, what are the steps? What are different steps involved in this? Because after all, we need to find the solution for this example by using formula E bar is equal to Q upon 4 pi epsilon naught R square A bar R, right? So this formula we are going to use. So in order to use this formula, you should know the vector, you should know the magnitude, you should know the direction, right? So first step is to find this vector. So let us assume this vector as R bar. This vector R bar is equal to, this vector R bar is equal to 1 minus 4. See, I'm just subtracting this coordinate. this coordinate minus this. So 1 minus 4 a bar x plus 2 plus 2
सर हेलो ऐकू येत नाहीये सर.
I hope now it is visible and audible. येतंय का ऐकू आता?
Yes, sir. It is audible.
Now what I have done is 2 points are given, right? I just have calculated the vector. So vector is calculated, then I have calculated the magnitude. Now I am calculating the unit vector. Unit vector is equal to vector upon magnitude. So r bar upon mod of r bar. So this is the formula. So how you can write this now? Minus 3 a bar x plus 4 a bar y minus 4 a bar z, right? And divided by, what is the magnitude? Magnitude is under root 41, right? All of you are getting this vector, magnitude of vector and unit vector?
Yes, sir.
Okay. Now next step is to use this formula to obtain the electric field intensity, right? So put all those values that we know into the formula and get the answer. So electric field intensity E bar is equal to Q upon 4 pi epsilon naught R square A bar R. This formula we are going to use. So we have calculated this, So just put on the values. Value of Q is given, it is 25 nanocoulomb. So that is 25 into 10 raised to minus 9 divided by 4 pi as it is. Epsilon naught is
10 raised to minus 6
9 upon
divided
36 pi. Correct, absolutely correct. Multiplied by, actually it is square of magnitude. So magnitude is under root 41, right? So under root 41 bracket square multiplied by unit vector is minus 3 a bar x plus 4 a bar y minus 4 a bar z, right? So this is divided by 41. So if you could calculate this term individually, if you are having calci, you can calculate this, including this one, and as well as you can calculate this one, and then get it divided. So I will write the answer now. If you calculate this by using calculator, 0.856 into bracket minus 3 a bar x plus 4 a bar y minus 4 a bar z right? So check whether you are getting this answer.
Yes, sir.
Okay.
Yes, sir.
So this constant, get it multiplied inside the bracket and obtain the final answer. So final answer for electric field intensity E bar is equal to minus 2.568 A bar X plus 3.424 A bar Y minus 3.424 A bar Z. And what is the unit of electric field intensity? Volts per meter. So this is the final answer. All of you got this?
Yes, sir.
And one more thing, some of you have made a comment of their roll numbers. Let me check because I got disconnected. So the students who have made a comment after B29, Urmila Shinde. Urmila Shinde, after that, those who have made a comment, I could not see those roll numbers. I could not see those names. So I request once again to make a comment. I can see only Rushikesh Deshmukh, Shubha Mausekar. Sir कुठे गेले? Okay. Sir disconnect झाले. Okay. B59 Aditya Pawar I can see. B36 Prajakta Shikre. सगळ्यांनी करायचं नाही. मी आता जे नाव सांगितलं त्यांच्या नंतर ज्यांनी कमेंट केलेली त्यांनीच फक्त परत एकदा टाका. ज्यांनी आधीच करून ठेवलेली कमेंट त्यांनी दे डोंट हॅव टू डू इट. ठीक आहे. सो one more example we can solve now. So I'm going to assume the same point charge at the same point. Sorry, at the same point I'm going to find electric field intensity due to some other charge. So another example. Find E bar at let's say 1, 2, 3. So I'm using the same point again. Find E bar at 1, 2, 3 due to Q equal to, so charge is given 60 nanocoulomb. 60 nanocoulomb means 16 into 10 raised to minus 9 coulomb. Located at let's say minus 3, 4, minus 2. So now the problem is we are having the point somewhere here, let's say point 1, 2, 3, and we want the electric field intensity at this point because of Q, because of this charge Q, which is 60 nanocoulomb, located at what location? Minus 3, 4, and minus 2. So because of this, let us find the electric field intensity at point 1, 2, 3. So let us assume vector is R bar, so that we can use electric field intensity at this 1, 2, 3 is equal to Q upon 4 pi epsilon naught. Same formula you can write once again, R square A bar R. Right. So to find this, first of all, we must find R bar. R bar is equal to, who will tell? R bar is equal to
1 plus 3 A
1
bar
plus
X.
A bar X, correct?
2 minus 4 A bar Y plus 2 minus 4
plus 2 minus 4 A bar Y
A bar Y plus
3 minus of minus 2 a bar z, right? So this would be the vector. So r bar is equal to, what we get is 4 a bar x minus 2 a bar y plus 5 a bar z. This is r bar. Now next step, we can calculate the magnitude of that. Magnitude of that is equal to 4 square plus minus 2 square plus 5 square. Right? Answer of this is under root 45. Right? So you got this unit vector. You got this magnitude. So unit vector a bar r is equal to r bar upon mod of r bar is equal to 4 a bar x minus 2 a bar y plus 5 a bar z, right? Divided by under root 45. All of you got this? Are you able to calculate this?
Yes, sir, got this.
Shall we move next? Now you can put the values. Just now we have solved the similar example. You have to use this formula. So for that, whatever is required is calculated. Vector is required, magnitude is required, unit vector is required. We have calculated. Now you can put the values. So E bar is equal to 60 into 10 raised to minus 9. This is Q, divided by 4 pi epsilon naught. Epsilon naught is 10 raised to minus 9. So 10 raised to minus 9 divided by 10 raised to minus 9, of course, it is going to be cancelled. 36 pi into, now I will write 45 directly instead of writing square of square root of 45. So 4 a bar x minus 2 a bar y plus 5 a bar z divided by under root 45. Right? So if you get it calculated, this thing, tell me the value. The value you can get it for this component. This constant, can you calculate? Now let me check who can calculate this for me. Too many people are there. Just a minute ago, Monica Shinde has made a comment, her roll number. So Monica Shinde, if you have calculated, you can tell me. Otherwise, Rushikesh Chavan will tell me if they are not sleeping. Can anyone tell what is the answer?
1.7
a bar x minus 3.576 a bar y plus 8.9 a bar z.
Okay, you are telling me final answer. Okay, I wanted the answer for this thing.
1.78.
Yes, sir. That's correct. 1.786 is the answer. Multiplied by, into bracket, 4 a bar x minus 2 a bar y plus 5 a bar z. Right? So if you multiply this inside the bracket, E bar is equal to 7.14 a bar x minus 3.57 a bar y plus 8.93 a bar z. And what is the unit? Unit is volts per meter. So this is the answer for electric field intensity at 0.123 because of charge of 60 nanocoulomb. All of you got this answer?
Yes, sir.
Next is so exercise for you. So if you could solve this example, then only your attendance is going to be marked. Now you have to write the answer into the comment for this example, right? After solving, you have to write the answer into the comment box. Write down the example. Example is 2-point charges. 2-point charges are given. 2-point charges. Q1 is equal to minus 3. Q1 is equal to, sorry, this is minus 0.3 microcoulomb, and Q2 is equal to 0.5 microcoulomb, right? Are located in free space, at a in bracket 25, comma, minus 30, comma, minus 15. This is in centimeter. And B into bracket minus 10, comma 8, comma 12 centimeter respectively. So if the dimensions are given in centimeter, what is your first task? You have to convert it in a meter, right? So you have to get those coordinates converted into meter. Find E bar at 15, 20, 50. Now this coordinate is given in meters, so you don't have to convert this in meter. So simply you have to convert this into meter. So let me tell you how you can calculate. So the point 15, 20, 50 is located here. 15, 20, 50 is located here, and you have to find the electric field intensity at this point. And this electric field intensity is generated or produced because of 2-point charges. Point charge Q1 is located here, Q2 is located here, right? So let's say this is point A, this is point B. Coordinates are given. You have to get it converted into meter before doing anything. And after that, after converting those points into meter, you can find the vector from A to that point. That will be your R1, and you need to find the vector originated from Q2 to that point called as a R2, right? So once you get those two vectors, once you get the magnitudes of those two vectors and the unit vectors of those two vectors, you can find electric field intensity E1. E1 is the electric field intensity produced by this Q1 at this point. So this is equal to Q1 upon 4 pi epsilon naught R1 square A bar R1, right? And second thing, you can calculate E2. E2 is the electric field intensity produced by this Q2 at this point. So this is equal to Q2 upon 4 pi epsilon naught R2 square A bar R2. So right, so those two formula you need to use to obtain the total electric field. So E total, simply you can write this as E1 plus E2. Start solving this example and tell me the answer. मी नोटबुक बघणार आहे सगळ्यांच्या. नोटबुक बघणार आहे सगळ्यांच्या. हा, नोटबुकचा स्क्रीनशॉट. नोटबुक वरती रोल नंबर लिहायचा आणि त्याचा स्क्रीनशॉट घ्यायचा. बस. दुसरा चालू. So what electric field you are getting for first charge? Electric field E1 is equal to 478 A bar X minus 2392 A bar Y minus 3100 A bar Z volts per meter. So this is the answer for E1. E2 bar is equal to 10,820 A bar X plus 2.8 A bar Y plus 13.35 A bar Z. So this is the answer for your verification. If you have calculated, it's good. If you have not calculated, you can use a same technique that we have used in last example and obtain the answer and cross verify whether you are getting the same answer. Yes. Workshop. Anybody got answer for this? Similar answer or approximately close to this answer? So next example. So next example is to calculate the force. So calculate the force between two charges. If a charge Q2 is equal to 121 into 10 raised to minus 9 coulombs is located at point P2. Sorry, this Q2 is located at P2. Coordinates of P2 are minus 0.03, comma 0.01, comma 0.04 0.04 meter. Find force on Q2. Find force on Q2.
सर
Huh?
सर पॉइंट्स आणखी एकदा सांगाल का?
कोणता?
कारण दिसत नाहीये, स्लाइड अर्धीच दिसतीये.
ओके.
P2 चे पॉइंट्स.
Q2 चे पॉइंट का? P2 चे. ओके. 0. P2 चे कोऑर्डिनेट्स घ्या. minus 0.03, comma 0.01, comma 0.04 meter. Oh, lecture चालू आहे. Oh.
ओके सर, थँक्यू सर.
And you have to find the force on Q2 due to Q1 equal to 10 microcoulomb. It's not 10 microcoulomb, it's 110 microcoulomb at P1, and the coordinates of P1 are 0.03, 0.08, minus 0.02 meter. So you need to calculate the force. So simple Coulomb's law is applicable here. By using Coulomb's law, you can obtain the force acting on Q2. So first step is to draw the neat diagram. So let us assume Q1 is located here, Q2 is located here. So what are the coordinates? Coordinates are given. Q1 is located at P1, Q2 is located at P2. So coordinates are given. So find this vector, because we want to find the force on Q2. So let us assume this vector as R bar, and this vector R bar is equal to minus 0.03 A bar, minus 0.03 minus 0.03 bracket complete A bar X plus 0.01 minus 0.08 A bar Y plus 0.04 minus 0.02 A bar Z, right? So this will be the vector. Now, if you calculate this, you will get some values are like this. Unit vector A bar R is equal to, of course, if you calculate this mod of R bar, I am giving you the answer. It is equal to 0.11. So if you take this R bar divided by mod of R bar, the answer would be minus 0.66 A bar X after calculation, minus 0.64 A bar Y plus 0.55 A bar Z. So hope up to this point there is no problem to calculate. Next आपल्याला calculate करायचं force on Q2. Force on Q2 is F12. It is equal to Q1 Q2, or as per Coulomb's law, Q1 Q2 upon 4 pi epsilon naught R12 square. So this you may consider this as R12. This is R12. This is R12. This is A bar R12. Right? A bar R12. So by using this formula, you can obtain the force on Q2. Now you can put the values. ఎలా డివైడెడ్ బై చేస్తున్నారు 0.11. नहीं, it's not divided by 0.11. It's actually calculated.
हाँ सर ते डिवाइड करूनच केलेलं आहे.
हाँ, डिवाइड करून दिलेलं. हे 55 येत आहे का 66 येत आहे? जस्ट कॅल्क्युलेट. इज इट 55 or
ते कसं 0.65
65? So let us put the values. F12 is equal to first charge is 121 into 10 raised to minus 9. Second charge is 110 microcoulomb. So this is 10 raised to minus 6 divided by 4 pi into 10 raised to minus 9 upon 36 pi into what is the magnitude? Magnitude is 0.11 bracket square into a bar R12 is minus 0.66 a bar x minus 0.64 a bar y plus 0.55 a bar z, right? So if you could calculate this, you will get 9.98 for verification for your cross checking. Answer is 9.98 into bracket minus 0.66 a bar x minus 0.04 a bar y plus 0.55 a bar z. So this force F12 is equal to minus 5.44 a bar x minus 6.33 a bar y plus 5.44 a bar z. Unit is Newton. Force. So hope all of you have calculated this force. If you got this, if you have written this for cross verification, now you can leave the class. Attendance की लिखी. शेवटी जॉईन होतो. मध्येच रॅन्डम. So anyone is having any doubt? Any doubt so far? Any doubt up till now? काही कळालं नाही असं आहे कोणाला काही?
No, sir, no doubt.
No doubt. ठीक. हो 37 जण अजून आहेत लेक्चर मध्ये, कुठे गेले? झोपले का बघा. आय टोल्ड यू द क्लास इज ओव्हर, यू कॅन लिव्ह, यू कॅन लिव्ह द मीटिंग. कमी व्हायला किती झालं, किती